In this video, I will show you why solar batteries fail early and how you can make yours last much longer. Now, the first reason is deep discharge. All batteries have their limits. We have what is called cut-off voltage or low voltage disconnect. Then we also have percentage. When you are deeply discharging your batteries every day, that battery will die fast, the cells will become weak, the batteries will not last as it is supposed to last because you are deeply discharging it every day. Now we have the lithium batteries and also we have the lead acid batteries. For lead acid batteries, the recommended depth of discharge is 50% DOD. Then for lithium batteries, some manufacturers recommend 80% DOD, some 90%, so some 95%. So the basic rule there is for lithium batteries, if you're discharging it, once it gets to 20 or 30%, the batteries should shut down. Then for lead acid batteries, if it discharges to 50%, the inverter should shut down. Now you can do this by setting your low voltage disconnect from the inverter. We have cut-off voltage or low voltage disconnect. Now for a 12 volt battery, let's say you're using a lead acid battery, that gel or AGM or flooded battery, we have use 12.2 volts. 12.2 volts. That is, your cut-off voltage should be 12.2 volts. But most times you find out that you are discharging the battery down to 10 volts. If you're discharging your battery down to this level every day, you're killing the cells of that lead acid battery. If you're using a lithium battery, set the cutoff at 20%. Once it gets to 20% or 30%, the inverter will shut down. This will help in prolonging the lifespan of your battery. The next one is overcharging or incorrect charge settings. If you look at your inverter, whether the hybrid inverter or the non-hybrid inverter, when you go to the settings, you always see something like charge voltage, you will see charge current. Now you need to look at the specifications of your battery. The manufacturers recommended charging current and charging voltage. So you have to impute these parameters correctly on the inverter so that once the inverter is charging the battery or the charge controller is charging the battery, once the current exceeds that value from the solar panels, it will limit that current. For example, you set your lithium battery to charge at 50 amps. So once it cannot exceed that 50 amps. Why? Because you want to stay within the manufacturer's recommended, specification. If a battery charging voltage for a 12.8 volt lithium battery is 14.4 volts or 14.2 volts, and you are using 15 volts to charge that battery, you damage those cells very fast. Then at times the charging current also, maximum charging current, you'll see 50 amps, 20 amps or 30 amps. Do your settings on the inverter or charge controller to correspond with the manufacturer's charging specifications. The next one is low quality or mismatched cells. There are a lot of low quality lithium batteries or lithium cells in the market today. So when you buy low quality lithium cells, when you buy low quality batteries, those batteries will not last long. They may perform very well for 2-3 months, and after that the battery will start degrading. The cells will start failing. If you charge it up to 100% at night, when you're using it, it will drain very fast, even when you are not connecting heavy appliances or heavy loads to the battery. So you have to be very sure where you're getting your lithium battery from. Buy your lithium battery or your lead acid battery if you want to use the tubular battery for small systems. Maybe just 1 or maximum 2 batteries for tubular batteries. Buy them from the company's distributor or dealer in your country, so that you will not fall into wrong hands. There are a lot of solar fraud happening in our countries today. So if you fail to take this into consideration, you will fall into wrong hands, and they will sell you fake or mismatched cells. They will sell you low quality cells, and these low quality cells will not give you good backup. The next one is overloading your inverter. When you overload your inverter, the inverter is dragging or taking that its power from the battery. So as you are loading the battery, the inverter is drawing or taking more current from the battery. And most times, the inverter will take more than the recommended discharge current from the battery, because the inverter wants to meet up with the loads that you have connected to it. So don't overload your inverter. Your loads should be according to the size of the inverter and also according to the capacity of your battery. If you want to connect more loads to your battery bank, you should make sure that your battery bank is able to carry those loads. So you have to either double your battery bank, or during system sizing, you size your battery bank accurately. You size your battery bank very well so that it will be able to power your loads efficiently without the inverter shutting down. Because as the inverter is pulling that high current or much current from the battery, the cells will become hot. At times, if you touch the terminals of the battery, they will become hot, and those things will make the battery to fail very fast. Another factor is insufficient solar panels. When you don't have solar panels sufficient enough to charge the battery during the day when the sun is available, that battery will never be fully charged. So at times, it may charge to 50 or 60%, and at night, your loads, your usage, you will consume everything that the solar panels generated during the day. So before you know, the battery will just shut down. So if you are connecting solar panels to a battery bank, make sure those solar panels are enough to sufficiently charge the battery during the day, depending on the available sunshine that you have. Another thing, if you are powering your loads during the day while the solar panels are charging the battery, you need to appropriately size your solar panels so that they will efficiently charge your battery and also be able to power your loads without any issue. As they are powering the loads, the SX, the solar panels are using it, sending the excess power to your battery. But when the solar panels are not sufficient enough, and you're using some appliances during the day, the solar panels will use that power to power your loads, and nothing will be left to store in the battery. So at night, you will just have minimal backup. You have minimal energy that is stored in the battery, and the battery will not take you overnight, will not last for long, even when you connect few appliances to that battery bank. Another thing is heat. Batteries don't like heat. If you look at your data sheet or your specification sheet, the manufacturer will always tell you the operating temperature, whether you are charging the battery or discharging your battery. So do not always go against the manufacturer's recommendation. At times, you install your inverters, some of them generate a lot of heat. You install them close to the battery. As they are generating that heat is being pushed to the battery. At times, the place is not well ventilated. So if it is not ventilated, there will be a lot of heat, and batteries are being affected by high temperature. So with that, as you are repeating it every day, you are degrading the cells and the capacity of that battery. So always install your batteries in a place that is well ventilated, so that there will be good aeration around that battery, so that it will stay within the manufacturer's recommended operating temperature, whether discharging or charging. And the next point is wrong cable size or wrong connections. At times, after connecting the inverter, the charge controller, or whatever to the battery, once in a while, try to shake, the cables that are connected to, the battery. You will see that most times they will be, shaking. They are not properly tight. You have to tight them very firm. And at times, you're using undersized cables. And when you are using undersized cables, the charge controller is pumping high current to the battery, and the inverter is drawing high current from the battery. Those cables will not be able to withstand that current that is flowing through them. So they will overheat, and at times they will affect the terminals of the batteries, and that can destroy the battery. Also, when the cables are not properly connected, and there will be some sparks, there will be arcing, and that also can cause overheating. So what you should do is you should always properly tighten your battery terminals and use proper sized cables between the battery and the inverter. Then the next one is poor system design. Anytime you poorly design your system, all components will not function well. They will fail. The inverter will fail, the solar panels will fail, the battery will fail, the charge controller will fail, even the cables, all the accessories you connect to the system will always be having issues. Why? Because the system is not properly designed. So before you, install your battery, before you buy any solar component, make sure that your system is properly sized. Your system is properly designed. You design your solar panels according to the energy you want to generate or harness from the sun every day. You design your battery bank according to the energy you need to power your loads throughout the night. Whether you're powering air conditions, you're powering refrigerators, you're powering freezers, lights, television, or whatever, your ceiling fan or standing fan, all designs should be correctly done so that your system will be able to power your loads whether in the day or at night when you need the system, so that your components will not fail. So thank you for watching. If you have any question or you have any contribution, please drop it in the comment section. Thank you for watching and see you in my next video. You have a lovely day.